Good day. This is our introduction to electrochemical cells. They're known as voltaic cells. They're known as galvanic cells. What these things have, well, Volta and Galvani, these were Italians that they've named it for, but these are all spontaneous. So these are things like batteries where we combine chemicals and they react, and as they react, they make electricity. They cause electrons to flow. So with electrochemical cell, the first thing we have to do is introduce you to the components of an electrochemical cell. So you have a diagram that looks like this. I would copy it not on this PowerPoint, but on the separate sheet you have. And we're going to label quite a few things. So here we have zinc and copper. So this solid material we're saying is made of zinc, and this solid material we're saying is made of copper. And electrodes are solids, and they're solid conductors that are a site for reactions to happen. The reactions can happen at the electrodes. This thing is called a U-tube. It's an upside down U right now. And in that U-tube we put an electrolyte, and often it's something like potassium nitrate or sodium nitrate or sodium sulfate, something that's not going to react. But what it does, it connects this half cell to this half cell. One of these reactions is going to be oxidation and one's going to be reduction. And this prevents the reaction from stopping. It allows it to carry on. So there's our salt bridge. We have something called the anode. The anode is always the site of oxidation. It's always where something gets oxidized, and anytime an element or a chemical gets oxidized, it releases electrons. It's called the anode because it attracts the anions. And we have something called a cathode, and therefore it has to be an electrode that's the site of reduction. That takes in electrons. The salt bridge connects the two half cells and prevents a polarity buildup. We can talk about that later on once we're more comfortable with all these terms. We're going to have an external wire. That wire is for electrons. And then we're going to have electrolytes. And we got an electrolyte in our salt bridge. And each half cell will have an electrolyte. So in grade 9, you should have learned that for electricity to flow, it needs a complete circuit. Well, in an electrochemical cell, what happens is electrons flow through from one electrode through the wire to the other electrode, but in solution, it's the movement of ions that completes the circuit. So let's look at a zinc-copper electrochemical cell. And when we look at our chart, we see copper 2 plus is above Zn 2 plus, so the copper 2 plus is going to reduce. And the zinc, which we find on the right, as a reducing agent, it's going to oxidize. So we took the plus 0.34 volts from the chart. We had a minus 0.76 volts, but it's oxidation, so that minus becomes a plus. We combine those numbers together. Here is our redox equation, and adding those, there's our cell potential. It's positive, so this is spontaneous. And I should have a video or a demonstration of this occurring. Electrons always flow from anode to cathode. So we look at this. At the anode, we've made electrons, and they're going to pass through the wire to the cathode. Copper ions in solution are going to collide with those electrons, and the copper is reduced. And this cell is going to make electricity for us. So let's label this fully. You have that diagram from earlier, and now we'll just complete it. So there's our zinc electrode. We know this is the anode. Copper is the cathode. So now we label our Zn here, our Cu, those are electrodes. We do our oxidation, half reaction, oxidation always at the anode. We do our reduction half reaction, always at the cathode. And the zinc is becoming zinc ions. So this electrode is going to get smaller. These zinc atoms are turned to ions, and so over time this electrode will start to disappear. Over here we have copper ions, and they're going to plate on to the copper electrode, so this electrode will get heavier. In the salt bridge, we're going to have ions moving back and forth. There's our 1.10 volts that we calculated. There's our nitrate, and nitrate is an anion, so it's going to go towards the anode. And then we said we had some potassium, it's a cation, so it's going to go through the salt bridge, and this can be things like cotton or glass wool, but these ions are small enough they can go through, but the water and things essentially get trapped by a bit of pressure. Now the electrons always flow anode to cathode. They're made here, or they go over here. Electrons there, copper 2+ hits them, and that's why it's heavier over there. So that's your introduction to an electrochemical cell. We have cell notation typically with the cathode, electrolyte, boom, 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 electrolyte to anode. What this is a physical barrier. This would be like a salt bridge separating the two half cells. That's why there's two lines showing a real big barrier. This is a phase barrier. Here we have the electrode, which is solid, with the electrolyte, which is aqueous, and another phase barrier on the other side. But you will find if you go from book to book, sometimes they don't put the cathode on the left, sometimes they put the anode on the left. But for our example here, here's how we would show it. Here's our electrode, electrolyte, the other half cell, electrolyte, and the other electrode. So that's your introduction, and there's some questions to work on, all kinds of fun, but we may have to give you a little more information before you attack them.